Welcome to the next session on the analysis and design of algorithms lab. Myself, Madhu Nagraj, Assistant Professor, Department of CSE Data Science, ATME College of Engineering, Mysore. Today, I'm going to explain the second lab program, that is design and implement a C program to find the minimum cost spanning tree of a given connected undirected graph using Prim's algorithm. So starting with, let's see what is this Prim's algorithm. So Prim's algorithm, so it is a minimal spanning tree algorithm, which is one of the efficient method to find the minimum spanning tree of any of the given graph. So what is a spanning tree? So a spanning tree is a tree where it does not contain a cycle. A minimum spanning tree is nothing but it is a subgraph of the main graph which connects all the vertices which are present in the main graph, and also it will be having the least possible edges and also the minimum cost. So that is why the name is given as the minimum cost spanning tree. So this Prim's algorithm is one of the type of the greedy algorithm, and we have already seen one more greedy algorithm, that is the Kruskal's algorithm. So Kruskal and the Prim's both are the greedy algorithm. So in this Prim's algorithm, it will always start with the first node or a single node, and then it will move through all the adjacent nodes in the graph, and then it is going to explore all the edges connected to the graph unless and until all the nodes are explored and all the edges are connected with the spanning tree. So how to find the minimum cost spanning tree using the Prim's algorithm? So the first step, we are going to start with the first vertex or the first node, that is the starting node. And then in the step 2, we are going to follow from step 3 to 5 unless and until all the vertex are included into the spanning tree. So the third step, we are going to find the edges which are connected to the particular vertex. In the fourth step, we are going to find the minimum among these edges. And in the fifth, we are going to add that into the minimum spanning tree only if it does not form any of the cycle. And in the last step, we are going to return the minimum spanning tree and we are going to exit. So this is the algorithm which is used to construct the minimum spanning tree. So input, it is a weighted connected graph, and output, we are going to get the minimum cost spanning tree. So we are going to start from the edges, that is from 1 to v minus 1. So as I told, so it is going to run for n minus number of times the loop, and we are going to execute the program. So let's see how the program is implemented or how this algorithm is implemented using the C program. So here first, so we are going to declare the variables which are required for the calculation purpose. N is the number of nodes and NE is the number of edges. So that is assigned with the value 1. So we have the variables min and min cost and visited of 10. So this visited array is declared in order to provide the value as and when we visit that particular node. So any node is visited, so that is added into the visited array. So that is why this variable is taken. And cost is mainly used for the cost adjacency matrix. So starting with the main program, so we are going to enter the number of vertices, and next, we are going to enter the cost adjacency matrix. So the loop runs from 1 to n, and we are going to read the cost adjacency matrix. So here we are going to check a condition if cost of ij is 0. So if it is 0, then we are making it as 999. So this is done because if it is not made it as 0, then every time when we check for the minimum cost in the spanning tree, then always the 0 will be considered, leaving the other weights. So we are going to take this as a minimum spanning tree. So cost of ij is done as 999. The minimum edge. So here visited of 1 is 1, that is the first node which is visited. So we are making it as 1. Printf. Then while n is less than n. So this while loop will be running for n minus 1 number of times. So n is the number of edges and n is the number of nodes. So it is always going to run n minus 1 number of times. So here we are checking two conditions. That is if cost of ij is less than min and if visited of I is not equal to 0. So if this both the conditions are true, that is whatever the value we are scanning in the cost adjacency matrix, it is less than the minimum value and it is not equal to 0. So it is not visited. So it is visited. So that is why then it will enter into the loop. So then the cost value, whatever it is there, it will be assigned to the minimum variable and the value in I will be assigned to u and value in j will be assigned to variable v. So this loop runs unless and until all the values in the cost adjacency matrix is visited. Next, we are going to check the condition if visited of u is equal to 0 or visited of v is equal to 0. So this condition, if any one of the condition is also true, then we are going to print the value because we are using the OR condition. So even if any one of the condition is true, then we are going to enter into the loop. So then we are going to print the adjacency, that is, we are going to print the edges, the minimum edge and the value for that particular edge. And then we are going to calculate the minimum cost. So minimum cost equal to minimum cost plus minimum. So each time when the minimum is assigned to the any of the value, any of the variable, then it is going to be added with the minimum cost. And finally, we are going to get the final value of the minimum cost. And then visited of that particular node is made it as 1, saying that we have visited that node and that is why the value is made it as 1. And finally, we are going to print the minimum cost. Before running the program, let's see exactly how this Prim's algorithm works. So consider this particular graph. So I have four vertices, 1, 2, 3, and 4, and the weights are given. So how to construct the minimum cost spanning tree? So the first step is consider the first vertex. So that is the starting vertex. So I'm taking 1 as the starting vertex. So we can start with any of the vertex. I'm taking it as 1. So how many edges are going out from 1? So I have 3 edges, 1, 2, and 3. So that is from 1 to 2, I have value 2, 1 to 3, I have 3, and 1 to 4, I have 5. So I have 3 edges which are going out from 1. So I have to select the minimum one among these 3 edges. So the minimum one is 2. So I'm going to consider the edge 1 to 2 and adding it into the spanning tree. So this is my spanning tree. So I'm adding this first edge as the edge into the spanning tree. Now I've landed to 2. So let's see how many edges are possible from 2. So from 2 I can have 1 to 3 that is 8 and 1 to 4 that is 9. Along that I have the other two edges also from 1 that is 1 to 4 and 1 to 3 which is having the value 5, 3 and here I have 9 and 8. So among these four values the minimum one is 1 to 3 that is 3. So I'm going to consider the next value as 1 to 3. So that is having the value 3. So now the remaining edges possible are 1 to 4 that is having the value 5, 2 to 3 which is having 8, 2 to 4 9 and 3 to 4 one more I can have that is 12. So these are the 5 edges, 4 edges which are possible. So among these 4 the minimum is 1 to 4 that is 5. So I'll consider that edge that is 1 to 4 which is having the weight 5. Now, if I had any of the other edges, that is 2 to 3 or 4 to 3 or 2 to 4, so any one of the edges added, then it will form the cycle which is the against of any of the spanning tree rules. So this is the minimum spanning tree which is possible. So the cost will be 5 plus 3 plus and 2 that is equal to 10. So this is the minimum cost which is possible for the given graph. Now let's execute this program and see for the same graph which we discussed just now. So enter the number of vertices. So the number of vertices we are having is 4. Enter the cost adjacency matrix for the graph. So let's enter the cost adjacency matrix 0, 2, 3, 5, 2, 0, 8, 9, 3, 8, 0, 12, 5, 9, 12, 0. So you can see we have got the same output as we discussed now. So I have 1 comma 2, 1 comma 3 and 1 comma 4. So that is 2, 3 and 5 and the minimum cost, that is the total minimum cost is 10. So the same answer which we discussed with the graph. So we have got the same one. So this is the minimum cost spanning tree which is done by using the Prim's algorithm. Thank you.